Hello, my wonderful beginning algebra students. So happy to be starting the week off with you. We are going to look at chapter 11 this week. Okay, so we're starting the next chapter. It is on data analysis. So we're going to look at various types of graphs you can do using different types of data. What I'm going to do today is sort of give you an overview. Okay, I'm going to walk through some examples of each one. This is in your book, so chapter 11, it starts on page 581. You might want to pause, get your book so that you can follow along, right? Page 581, chapter 11. And we're going to look at different types of data and how you can display those. Okay, so we're going to go through stem and leaf plot, histogram and frequency tables, and then box and whisker. Why they have such crazy names, I don't know, just to keep you interested. Well, today I'm going to give you the overview. Then on Tuesday and Wednesday, you're going to work on some of those, making those graphs specifically. I have added resources in Google Classroom. So if I go through this today and you're still stuck on, oh, I don't get stem and leaf, or I'm not sure about that histogram thing, or how do you do a frequency table, I have put some additional resources in Google Classroom that may help you. Some of you that like to read it and go through the examples, that's an option on there. Some of you that like to hear it from somebody else, just another way to explain it, jump on there. There's good resources, and those are each to help you day by day. On Thursday, you're going to take a quiz over all of these three concepts. So by Thursday, you're going to need to have this pretty well down. If you have questions, maybe something I go through today, I go through quickly and you're not sure, maybe as you're practicing it, you're like, well, I don't really understand how to graph this or how to organize my data. Again, I'm available on Google Meet. So Mondays and Wednesdays, just Monday and Wednesday, now that we're changing our schedule up, I'll be on there from 1 to 2. Okay, I have some other classes that I've given different time slots. So if you want to come on and ask me a question or explain a problem, I'm happy to do that. If you want to just say, well, I want to make sure I'm doing this right, jump on there, 1 to 2 on Monday and Wednesday. All right, so today, let's start on page 581. And the first one we're going to do is called stem and leaf plot. Okay, so instead of me giving you a bunch of new data, I'm going to use what they give you. And we're going to look at how they organize that. So stem and leaf plot is something that they always divide with a line down the middle. Now, on this side, I tend to think of it like you keep the smallest number, the ones portion, on this side of the vine. So here's my stem, here's my leaves, okay? So if I look at the information on page 581, all right, they're talking about distances in a long jump competition, okay? So you'll see at the top they give you these numbers, 669, 702, 644. The first thing you want to do is put them in order, okay? It does matter. So the first thing I would do is rewrite those numbers and put them in order, okay? So the smallest number there, if I make sure, is 644. I'll look at the next one, and I believe it is 662. And then we have 669. Is it killing you? 73. And then 670. 673. 676. All right. I'm going to start with that just because that gives us a good basis for what we're going to do. So what I'm looking at is this portion of all these numbers belongs on this side, okay, on the leaf side. All right, so I'll look at this. So my first stem, as we say, will be 64. That represents 644, okay, when I put those together. Now, you keep this in order. This side has to go smallest to largest. That's important to remember. You can't just do it by what the numbers are. So that's why I would put them in order first. And you see here, you've got a pattern 64, 66, 67. It's pretty pretty small increments. It goes up to, let's see, 702 is my highest number. So I'm only going to end up going up to 70 here. Okay? So going by ones works for this stem and leaf plot. All right? So this all goes by ones. Okay? And I have 644 as my first. Here's my leaf. Okay? I don't have 640 anything else. That's it. I actually don't have anything in the 650 column, so I just leave it blank. When I get to 660, I just have 669. Did I miss a number? Okay. 660, oh, 2. So I first have a 2, and then I have a 9. Okay, they don't always put commas. That's fine if you do, okay? Because I have 662 and then 669. This shows me, okay, that's my other leaf in the 660 stem. All right, 670, okay, is my next one, and you have to make sure then that you put a 0, okay, for 670, 673, 676. Kind of see how that's going? Okay, the important thing to remember is in this column you should only have one. So however big your number is, that number goes over here, okay? And your smallest portion goes on that right side, on the leaf side. Again, make sure you put it in order, okay? These go from least to greatest. These go from least to greatest, okay? Math. Put it in order, okay? It's very important. So that's how you do a stem and leaf plot, okay? Sometime they may ask you for the mean of those numbers or the median. Hopefully you remember those. Mean, we say it's like finding an average. You add them all up and divide by the total number, okay? The median, you would find the middle number. In that case, again, you have to have them all in order to find the median, the middle number. Mode is the number that occurs most frequently, okay? In this case, I didn't look carefully to see if there was a mode, okay? So, stem and leaf, all right? That's the first way you can organize data. The next one is a histogram. Now, a histogram always has a frequency table along with it. When you were a kid, probably your favorite way, they would have you make graphs all the time, right? And most kids love to make a bar graph, right? And so, oh yay, we have this many, and this many like dogs, and this many like cats, and this many like bunnies, right? So we loved that when we were kids about making a bar graph. A histogram looks like that. However, there will be no gap between each of these bars. And the difference is, so this might have been, you know, whatever it was, and your numbers go up the side, right? In this case, let's just say this was 1, 2, 3, 4. We'll do the same here. 1, 2, 3, 4, 5, 6. Okay. In this case, where we might have said dogs, cats, right, for ideas, a histogram works in intervals. Okay. So let's say we asked students their favorite animals. Okay. And so we said, all right, dogs, cats, bunnies, and we're going to go with snakes. Just for the sake of this, and we're going to assume that Jason and Cameron both probably want snakes. So we're going to say, yeah, 2 people are in the snake category. We have 4 people in the bunny category, 9 in the cat category, tallies, okay, and 12 there. Okay, so our numbers go from 2 to 12. Okay, so that's, I look at my range of numbers and I think, okay, I've got to divide that up into intervals. So I might say my intervals are 0 to 2. Okay, and you want to make sure that these remain the same. I'm going to go ahead and do 0 to, just to keep it 0 to 5, 6 to 9. Let's go. Okay. Now, how many people are in the 0 to 5? Okay, we've got 2 here and 4 here. So that means we've got 2 that fit in the 0 to 5 category. How many fit in the 6 to 10? We've got 1. And how many fit in the 11 to 15? We've got 1. Okay, so then you graph based on intervals. Okay, so this interval is no longer are we doing this, right? We're doing how many were in the 0 to 5. Okay, that's 1 bar. And how many were in the 6 to 10? That's the next one. And you have no gap because there's no gap in numbers. Okay, so we had 2 here. All right, in the 6 to 10 we have 1. Let's make it a little lower. All right, in the 11, 15, now you would do this much neater, I'm sure. Okay, you have it in that 1 category. So, the difference being when you compare to what you've done previously with bar graphs when you were young, now you're looking at intervals, okay, instead of looking at just this kind of information. You're graphing a histogram according to intervals. So, histograms always have a frequency table that shows your interval and it shows the tally marks. How many of those numbers were in that interval, okay? So if you look, let's look on page 582, all right? They give you an example about hurricanes, okay? And you look at, it says the number of weeks into the hurricane season in which Atlantic hurricanes occurred. Okay, so they're looking at the number of weeks. You look at all those numbers there. They start with 6, and the highest number in that set of information, that set of data, is 26. Okay, so then they looked at all those. There were a lot of occurrences, and they divided it into weeks. 6 to 8 weeks, 9 to 11 weeks, 12 to 14 weeks. You can see right on that table on the bottom of page 582. Again, tallies, okay? How many had between 6 and 8 weeks? 2. How many had when the hurricanes came between weeks 9 and 11? 1. 12 and 14, okay, there they had 8. So you have that frequency table, okay, that shows your tally. And then if you look on the top of page 583, they use that tally information, those intervals, to make the histogram. You'll notice the histogram, there's no space in between the bars. You'll notice along the bottom are the intervals, 6 to 8, 9 to 11, 12 to 14. And then up on the left side, 0, 2, 4, 6, 8, those also go in even intervals, okay? And that's where your tally is. Okay, so if you look at it and you're looking at that information, so then somebody looking at that histogram might say, oh, I can see that most hurricanes occurred between weeks 15 and 17 of the hurricane season. Okay, that's when the most hurricanes occurred. When did the fewest occur? Well, between weeks 21 and 23 and between weeks 9 and 11. So you use that information and interpret that data, all right? So that's the histogram and frequency table. Remember, those always go together. Again, you make mathematically sound decisions when you determine an interval. Okay, you look at your smallest number, you look at your largest number, consider that range. Is it best to go by 2s, by 5s, by 10s? How big of a range are we talking about? So intervals could be different depending on, you know, who's making it, but usually there's a logical sense, a logical division of intervals. Okay, so pay attention to that. And the last one we're going to look at is box and whisker. Yes, I know, the craziest thing. Page 588. So let's look at box and whisker plots. Page 588 in chapter 11. This is section 11.3. You're going to do a lot more practice with this on Wednesday. Again, I added extra resources in Google Classroom for this. So box and whisker has, to me, the most specific of all the information. You're going to really evaluate a lot of details with a box and whisker plot. All right? And you'll notice that these plots have a box in the middle-ish of them, and then an outline whisker on both sides that shows the highest and the lowest value of your numbers. So if you look on page 588, box and whisker. Okay, let's just look at the example they're using. A farmer is recording the number of oranges that an orange tree produced for each of the last 9 years. Okay, so they give the data there. Guess what you should do first? Yes, put it in order. Okay, I knew you said that, so great job. Okay, you put it in order. You start with 264 and go up, and the highest number is 572. I'm jumping down to where the example 1 is, okay, down below. You can see they wrote them all in order. 264, 360, 380, 407, 452, okay? So once you have them all in order, the first thing you're looking for is dividing them into halves. So you take the middle number if there's an odd number, okay? If it's an even number, you will average the two middle numbers, okay? But in this case, you have 9 pieces of data, so that middle piece is 452. That's your median. That's your first step, okay? Now, you'll notice they make a number line, and they start their number line at 250. If your information, your data, starts in the hundreds, don't start your number line at 0, right? You're going to make this make sense for you, okay? So they start it here, and okay, it starts down here at 250, and the last number on this is 600, okay? So you always need a number line. You graph a box and whisker plot on a number line, all right? And you see the median, okay? So the first thing that you're going to do, now sometimes box and whisker are above, sometimes they're below, it's okay. The first thing that I would do is put the median on there. So this goes by, let's see, 300, 350, 400, 450, 500, 550, 600, okay? So my median there is 452. Okay, so here's 450, so I put a dot right here, okay? I'm going to go with that's about 452. I also put dots at my highest and lowest numbers. So the greatest number we have there is 572. I'm going to go right there. And the lowest number is 264. All right, so we're down here. All right, so we've got those 3 points plotted. All right, now you're looking at quartiles. Okay, what does that sound like? Quarters, right? So we're basically looking at the lower portion. If the median's at 452, you can see there are 4 numbers in the lower half, right? 264, 360, 380, 407. Again, if we had a different set of numbers and there were 5, I would take the middle one, okay? But they don't. So I take 360 and 380 and I divide them by 2. I find the average and I get 370, okay? So 370 is about right here, okay? I'm going to graph that, and here, this will help me remember. That's my lower quartile, okay? Now I need my upper quartile. So I look at the numbers above the median. There are 4 again. I'm averaging my 2 middle numbers, and I get 459, okay? Probably should have written on here, let's see, this was 452. That was my median, right? This was 572. This was 264. My lower quartile was 370, okay? My upper quartile, you can see, is 459. So we're pretty close to this one, right? I'm going to write UQ, upper quartile, 459. So your box and whisker plot goes from your lower quartile to your upper quartile, and that's where you make the box. Look at that, box and whisker. You put a line here at your median, so that's identified. Okay, there's your box, and you extend the line to your greatest value. There's one whisker, and you extend this to your lowest value, your other whisker. Okay, and that is how you get a box and whisker plot. All right, so make sure you pay attention. You put your numbers in order. Count again and recount if you miss numbers. Get them back in there. Okay, that's making a box and whisker, the short of it. I just want you to look real quick on page 590. Okay, on page 590 they give you 2 box and whisker plots. Okay, so you're looking there at Boston and Seattle and their temperatures. And a box and whisker plot is a really neat way to compare 2 sets of data. So you can see there Seattle has the higher the higher median just by ½ degree, okay, at 52. Boston has the widest range of temperatures, but you're comparing 2. So in one of your problems, you will be comparing 2 sets of data. And so that's how you do that. You just put them on the same number line and you identify which one is the different sets of data. So, hope that helped. Again, if it was fast, watch it again. Or there are other resources that I've given you on Google Classroom. Try those, see if something else works. You have some work to work on today, and I believe it's stem and leaf plot. Back to that first one, maybe the simplest of all of them. And then you'll do histogram and frequency table on Tuesday, and you'll do more box and whisker on Wednesday. Hope it goes well. If it doesn't, I expect to see you at Google Meet 1 to 2. Have a great day.